Hello, and welcome to Chapter 1 of Business Statistics. Today we're going to be talking about data and decisions. So we're going to a little bit be doing an introduction to the course and what it's about and what we're going to be able to use statistics to do by the time we complete the class. So let's get started. What are data? Hey, I'm sure if you've been paying any attention to the world around you, we know that there's lots of information that we can acquire that can help us do better business. You might be immediately cringing and thinking, did she just say what are data? Yes, data is plural. It's not what is data. What is data would be singular, and data has lots of parts to it, and it definitely is plural because there are lots of pieces. If you had one piece of data, that would be a datum, and then you'd be saying, what is datum? So there's how you could singularize it. So sorry if that made you uncomfortable. So basically, we're going to be looking at large collections of data. These are usually held in something called a data warehouse. And modern businesses do have lots of different collections of data and lots of ways to acquire those. So most popular amongst all the data gurus nowadays is what's the notion of big data. So if you've never heard the term big data before, it's a data set that traditionally would have been so large that you absolutely can't use it to do anything. Usually these are so vast and so complicated that we previously were not able to get a handle on what was going on with them. And the current standard is that a piece of data or a arrangement of data in your repository or warehouse is considered to be big data if it's larger than 50,000 cases. You should be looking at me and thinking, oh wait, you can't see me because this is the internet. What's a case? We're totally going to get into that. So think big, large, and time consuming. As you may know, 50,000 isn't all that large depending on what you're looking at. So that I'm assuming as time goes on, this number will change. All right. So most companies that are selling products are using what they call transactional data. Transactional data is something acquired from making purchases, and usually what we want to use with transactional data for is to make predictions about purchases. Mostly this is involved in like what you see with offer programs. So if you've ever gotten a coupon in the mail or been emailed something that was a coupon or received an offer on something or a notice about what they have on sale, flyers, things like that, what businesses will do is monitor how they contact you and then see if that changes the amount of transactions you make with them. What seems to increase our business? What seems to encourage people to visit us instead of a competitor? So what we want to do is we want to take transactional data and gain some useful information about it, either make a decision or a prediction like, oh, I've noticed if I send out my coupons on Wednesdays instead of Thursdays, I get more business on the weekend, things like that. And we also want to make predictions. Oh, where's the market heading? Should I be offering more towards this market? Should I be moving towards offering certain things? The biggest prediction that I've seen change in the last 10 years ago when it comes to transactional data is Target started offering food items because they noticed that they were seeing a increase in the number of sales in their dry goods. So stuff they offered like candy and soda, and they started to ask themselves, oh, well, if people will come here and buy food along with other items, why don't we offer some general things like milk, eggs, dairy, things like that for people? And that's sort of expanded if you've been to one lately. And that's just one example. There are many examples of this. So some of you will go on to take different courses on how to take this even further. There's at Northwood demographic data mining, which is a much more predictive element of this class, is saying where can I take this, what do I think is going to happen next. So we're going to be focused more on what are called business analytics, which is trying to describe data or studying data analysis so we can use them to drive decisions from what we see in observations. All right, so big difference between math class and statistics class. Although statistics is a branch of mathematics, the one thing that's good about it is all of the things you will look at in this class will have context. What do I mean by that? So back when you were in algebra, you'd do things like, oh, I got an equation and I'm going to solve it because that's what the directions say. And I'm going to solve for x and I get 4. X is 4. Well, for what? I mean, stats looks at this and says, hey, I really, really care about what this is. What can I do with this? Where is it useful? When did I acquire this? And who is it from? In stats, your 4 should represent something. Maybe 4 is the average number of transactions a week you get with particular types of customers. In which case, hey, that's useful. It's 4. How can I increase that? How can I change it now that I know what it is? Other examples for things like this, you might ask, like, who are my customers? What's their average age? What do they tend to look like? What sort of income bracket are they from? What race are they? Can I do things to offer specific things towards that age group and increase different age groups? How can I spread my footprint for who's visiting my stores? Things like that. Again, I'm using transactional examples here. If you're looking for a not-for-profit, you should be asking things like, how can I serve more people, and things like that. There's other analogies besides just selling things. Anyway, so what I want to focus on here is, now that my information has context, I need to be very aware of where that context comes from and making sure that I'm acquiring good data, data that I know enough information about to where I am sure that it's from a good source and I know that it's applicable to what I'm trying to do. So below I have a data table for you with some information. I've got order numbers and names and area codes and what they ordered. Well, you know, the artists they ordered. So as you look at this, the table itself tells us the what, so to speak, of here. And you should wonder about, like, who collected this data and what purpose was it? How was it collected? Where was it collected from? And when? When is very important, especially when it comes to certain data types. If you're using data from 30 years ago and you think your group of individuals has changed, you probably shouldn't be using that data. That doesn't mean it doesn't hurt to look at historical data and to predict about the future. I'm just saying that if that's all you have, that's probably not good enough. You should go collect some more. You know what I'm saying? Let's do this. Okay, so here's how we organize our data. When we look at individual rows in our data table, we call them cases. Now, depending on how you acquired those cases, they also may be called different things. If your individuals are gathered from a survey, we call them respondents. If you have people that are in an experiment, we call them subjects or participants. And then if they're other inanimate things, we call them experimental units. I personally have a hard time calling an animal an experimental unit and usually call them a subject because I feel like they have more, I don't know, aliveness than a website. But you never know. Anyway, yay, personal opinions. So as you look at this, you should be thinking about, oh, what are the cases? So as you look down a row, that's just one case. So I'm going to just highlight a one at random. So I'm going to do, that's not the highlighter. That looks excellent. Let's erase that. Sorry about that. Well, I picked Chris basically because he's kind of in the middle. So Chris is this one individual case. I am assuming this is transactional data, so this is probably a subject. They may not have been aware or responded to a survey, but because they were purchasing items. But there's one case of my data. Alrighty, so the next thing we want to do is we want to look at the characteristic that our cases contain. These are called variables. Now, usually when it comes to data organization, our variables are formed by the values or the labels that appear at the top. So I'm talking about things like order number, name, state, country, price, I'm not reading all these. The big thing about this is you are very used to the idea that variable is an unknown quantity and there's just one thing and I got to go find it. When we're talking about statistical variables, we're talking about collections of information and how they're organized. What do they share in common? So all of my orders share an order, have different order numbers. All of my cases have a price that came from those cases. You know, these are characteristics that our cases have. So you should be thinking about them as collections of information instead. Now, that's not to say that we're not going to be able to predict things about our variables and acquire data beyond what our data values have. That is definitely something we're going to be able to do the second we hit chapter 4. But as you look at this, you should be thinking, oh, what did I measure? Those make my variables. Alrighty. Now, in addition to just your collection of data, or spreadsheet, is usually how these are represented, fun facts, we usually have our data with our variables as our columns. You should be thinking about what we call metadata. This is the how, where, and when. And usually why, like what was the purpose of this study that we're looking at. And then who is more or less who's in the data set. And as you look at this, when you're collecting data or using someone else's data to analyze something, you should have most of these and know most of them to be able to proceed forward. If you don't know most of them, you should worry about where your data was acquired from, whether or not it's appropriate to use to try to make the analysis that you're making, and so on and so forth. Alrighty, so Just so you're aware, I'm going to talk about relational databases, which is where most of the world is at. We will not be doing relational databases in this class, but I want you to be aware of them because you might be using them in your future classes. So if you have a data table that's a little bit more complex, rather than keeping one single giant spreadsheet, what we do is we call upon the idea of relational databases. So you'll notice that relational sounds a lot like relation, and it's like, hey, I are relating my different pieces of data by specific relationships that they share, or items that they share, or more specifically, variables that they share. They might not share all of them. So here's an example of one of them, just so you can see what they look like. It might be the case that you keep your tables organized by what type of information you're looking at. So I've got 3 tables here, so these would be 3 separate databases that we relate into relational databases. So I've got customer, items, and transactions. Those are my 3 tables. And then in each table, there's something that they all share in common, like customer number or product ID, that allows you to relate these tables across each other. And this is much more typical of how data is organized, just so you're aware. If you've ever used Microsoft Access, Access tends to organize using relational databases rather than giant tables like Excel does. We're going to use Minitab, which likes Excel things and big tables of stuff. All right, let's do an example. Keep you peppin'. When you approach examples, since this is your first chapter with me in statistics, I would suggest that you, I'm going to read most of these out loud, and if you find my voice annoying, maybe don't do that. You read them to yourself. And then what I would suggest you do to kind of work your way around, the answers literally are coming up next. So what I would suggest you do is maybe try to answer them yourself, either on a sheet of paper or in your head, or however you like to go through this, and then ask yourself, ooh, what do I think the answers are? And then we'll go over the answers. And then you'll know whether or not you did stuff right, and you got to try, and that's fun. Anyway, so Carly, a marketing manager at a credit card bank, wants to know if an offer mailed 3 months ago has affected customers' use of credit cards. To answer that, she asked the information technology department to assemble the following information on each customer. I'm assuming she's only looking at the customers that were actually in the offer that she mailed, because otherwise this would be crazy. Anyway, total spending on the card in the 3 months before, so the pre-spending, and then total spending for the 3 months after. This is called post-spending. The customer's age, to see if certain age groups are spending differently. The kind of expenditure made, was it entertainment? Was it to pay bills? Stuff like that. If the customer was enrolled in the website, so did they actually use the digital version of their bank? What offer were they sent? So were there certain offers that prepared a little bit better than others, induced more business than others? And then the amount each customer spent on the card in their segment, so in their specific grouping segment that was explained earlier. Anyway, we're going to identify the cases and the variables and describe the W's that you can for this data set. So if you want to, I would pause now before I go through the answers and try to answer them yourself. Alrighty. So, hey, the cases are the individuals that, are customers of the credit card bank. The data is the internal records of the bank, so the last 6 months of the banking period, so the 3 before and 3 after. The variables we would include would be account ID, amount charged on the card before pre-spending and after post-spending, the offer that was sent out, the customer's age, marketing segment, whether or not they enrolled in the website, what offer they were sent, and then the charges on the marketing segment that they spent. All right. So, what are the different types of variables? Okay, the big 2 we're going to look at are what are called categorical or qualitative variables. Qualitative is the older name, so just so you're aware, you'll see it every once in a while in certain examples, but more often than not, we're going to go with categorical. We think of categorical as things that you might answer like yes or no, male or female, question answers, what's your education level, how, do you feel about your shopping trip, was it poor, good, or excellent, things like that. Variables that measure numerical quantities with units are called quantitative variables. And the big end all to be all in this is, does it have units? If it doesn't have units, it can't be quantitative. And you need to be very careful about that, because there will be some things that feel like, oh, that should be quantitative, when actually they are categorical. So if you've ever taken a survey or rated something that you've purchased according to different scales, you have probably done a categorical thing that felt like it might be quantitative. So for instance, if they ask you to rate your shopping experience from like unsatisfied as being like a 1 to satisfied as being a 5, you're like, well, I entered in 1 through 5, there's a number there. But what are the units? It doesn't have units, so that would actually be categorical, not quantitative, and you need to be careful about that. Okay, so be careful. Categorical, we should be thinking yes or no questions. What kind of advertising? What's your class and school? Freshman, sophomore, junior, senior? Would you recommend this course? How satisfied you were with the product? But don't be fooled into thinking, oh, if it's numbers, then it's not categorical, it's quantitative. There are some things like zip codes, and I'm highlighting this for you, that are numbers, but they have no units, so they don't actually behave like quantitative, they're categorical. However, if you're looking at quantitative, it definitely has to have units. So, you know, some type of measurement, how much was spent on something, how far apart two values are, distances, things like that are all quantitative because they have units, like feet or dollars or inches or percentage, stuff like that. So the reason why we separate these into these two big groupings is that these really tell you why the data were collected. So for instance, like age is obviously a quantitative value. We usually measure it in years. If you're one of those people who wants to measure your life in months, that's really interesting. Your 36-month-old is 3. Stop doing that. But they can also treat age as something categorical, like child, adult, senior, stuff like that. And that's also fairly common. So depending on how you want to or why you're collecting the data, you're going to maybe arrange these in different manner. All right, the last type of variable we're going to talk about are what are called identifiers. These are something that's unique to the individual to help recognize who they are. I'm sure at some point in your life someone has asked you for your ID. Yeah, ID stands for identifier. These are tracking numbers, a way to identify different groups of people from away from each other or individuals away from each other. I'm assuming you all have a social security number, or maybe you have a driver's license, maybe you don't, but you all have student ID numbers. Hey, those are an identifier. Identifiers have to be unique. They have to be something that they can't share in common with anyone else, and that is the only characteristic that an identifier must have. In general, we treat identifiers as categorical because they don't have units. So it's kind of like a special kind of categorical, but it's not really a categorical because, you know, everybody has a different category that they're in, and that's weird. And you gain nothing by trying to analyze identifier variables. They're more or less just so you can keep your cases apart from each other and serve no other purpose. Oh, all right. The second other splitting that we're going to see is that when you're considering a categorical variable, there are two types. The nominal ones are ones that have no ordering to them, and then ordinals are ones that you can order. So, you know, you can order employees by time that they've been working at the company, seniority, this is usually called, but you wouldn't be able to order them based on the division that they work in. You wouldn't be able to say like, oh, well, the surgical unit's more important, so I'll put it as number 1. They need to have some sort of natural ordering that they already have. So if you're trying to think of an example of this, another natural example you might be is like grades you get on your report card, because you don't have those anymore, you're adults. Your report cards used to have like letter assignments between A through F, and sometimes you have pluses and have minuses, but you all intrinsically know that an A is better than a B, so there is some natural order to it. You would call this ordinal because it's categories. There's only a certain number of groups. They don't have units, and you can find a natural order to it. One is greater than the other. So in general, when you're asking yourself about is it nominal or is it ordinal, the end all to be all is, can you find an order, a way that you can find one to be greater than the other or better than the other? Alrighty. The other types of data we're going to see are what are called cross-sectional data or time series data. Time series data is measured over lots of time units, so usually measured over months or years or quarters. So this is like looking at sales of a company across the last like 16 quarters and asking is it increasing or decreasing. Cross-sectional data is when I look across one time unit for multiple pieces of data. So instead of just looking at one store for multiple quarters, you could look at all of your stores for just one quarter and ask who's behaving the best, who's got the best sales for that quarter. You can mix and match with time series and cross-sectional. You can have data that does do both. So just so you're aware. Alrighty, here's an example of some data types. Okay, so we're going to go back to Carly. She's still trying to figure out things with her sales for her offers. And we want to know, the data that she's gathered, is it quantitative or categorical, or maybe both? Could be. And then we're going to ask, is it time series or cross-sectional? So we're going to take her information and ask what are her quantitative variables. And once we know they're quantitative, we can ask what are the units. I usually do that the other way. Does it have units? If so, then it's quantitative. And if I've got a categorical, then are they nominal or ordinal? Do they have an order? Think nominal, no order. Ordinal, or it has the word ord in it. It's like, I have order. Anyway, I say like too much, or all other things. Do things. Let's do stuff. All right. So we're going back to the example. We had count ID. This is categorical and very much nominal and very much an identifier. So if you'd have just wrote identifier for that, that makes sense. Pre-spending, that's a money amount. That's definitely got units. This is going to be quantitative. Post-spending, also quantitative because it has the dollar unit too. Age, we're going to treat this as categorical, but we're also going to treat it as ordinal. You also could have listed this as quantitative depending on how they listed it. So if they said age group maybe, and they told you these are the groupings we're going to use, that's definitely more categorical looking than straight up, hey, how many years have you been on the planet? Or how many times have you gone around the sun? And that would be like, oh, I'm 14.6 years. That's definitely more quantitative unique looking because it has a unit, years. Anyway, segment, this is going to look categorical because it's going to depend on which marketing segment you're in. Did you enroll or in the online website that they have or not? That's a yes or no question. That's going to be categorical. Which offer did you receive? That's whatever number of offers she had. That's separate categories. That's very categorical looking. Also nominal because, well, I'm assuming one group of, spending offer isn't necessarily better than the other. You want to see which offer from comparable offers appears to be better. Okay, and last but not leastly, how much did you spend in that segment? That's quantitative, hey, because it's dollars, which is the unit. All right, the last thing we need to note is that this data is cross-sectional. Since we do not have more time units that we're looking across for this, we're looking at lots of individuals at one point in time, a 6-month period, so just that 6 months, not multiple 6-month periods. This is very cross-sectional looking. All righty. So when you're gathering your data sources or you're reading an article that contains data, these are the things you need to ask yourself to decide whether or not that data is a good source or they've given you enough information to where the data is useful. The first thing you want to look at is when. If it's too old, then that's concerning and you really need to know, like, when was this data gathered? Next, you should ask, how is the data gathered? One of the things we're going to talk about later in this class is how to sample and sample well. If it looks like they, gathered this in highly suspicious means, you should probably not use this. Or if it seems like their data was gathered and offers no insight to the type of questions they were answering. So if it's nonsense, don't use it. I think that's pretty obvious, but hey, watch out. Some people try to do that. The next thing you want to ask yourself is where. So my example down below is if you have data collected from Mexico, it's probably not the same as data collected from the United States. This comes from some healthcare data that I had that someone was trying to use to say something about the American healthcare system. Despite the fact that the data and information was from Mexico, our two systems are very, very different. You really shouldn't try to do that. In general, you shouldn't try to say something using data from a different location or source about a different location or source. All right, so how do you find data? Well, you can be the one performing an experiment or giving out a survey. This also can be found on public or private agencies. If you've ever been on the uscensus.gov website or their data collector, I think it's called Data Ferret now, which I think is kind of hilarious. There's lots of public data out there. I'll list some website for you guys that have lots of information out there for you. Also, a lot of internet sites will keep in track and offer publicly free information about them. Google Sites does this also, in case you were wondering. Alrighty, let's go back to that credit card bank example. I have overused this one and totally should come up with more. Anyway, on the basis of her initial analysis, Carly asked her colleague Ye Ming to email a sample of customers from the travel and entertainment segment to ask about their card use and household demographics. So she wants to gain additional information from these individuals. And then she asked her another colleague, Greg, who spells his name with 2 G's, and I say Greg weird, and I'm sorry, to design a study about the double miles offer. I've been doing this for too long because I'm getting distracted. In this study, a random sample of customers receives one of 3 offers. A standard double miles offer, so this is a airplane kind of thing. If you've ever owned a credit card that offers you miles for travel. A double miles offer, good for any airline, so that's good. It's like, hey, you can use it on any airline, or no offer whatsoever. So this is our baseline group we're going to compare to see what normal spending looks like. Let's take a look at this. So here's what we want to know. For each of these three data sets, Carly's original, Ye Ming's, and then Greg's, state whether they come from a design survey or an experiment, or if they're collected some other way. So take a minute to think about this. I'm going to give you the answers. So here's the thing. Carly was given transactional data that she already had. So this isn't a survey or experiment because she did nothing to manipulate the data. Well, Ye Ming is definitely doing a survey because she's asking them demographic information. She's sending out questionnaires, basically. Greg is the only one who's doing an experiment because he's assigning them to different groups. This is the major difference between those. So he had 3 groups that he was assigning these individuals to see how their spending changed. The no offer, double miles anywhere, and then double miles offer to see how their spending changed. So he's the only one doing an experiment. Go Greg. So now for a cautionary tale. What can go wrong? Don't label variables incorrectly and then you won't have a problem. Don't assume variables are quantitative just because it has a number. This is something I see happen all the time. Zip codes have no units. They're still a number. Doesn't mean a thing. Be careful. Ask yourself, does it have units? All right. This is good life advice. Always be skeptical. One of the things you're going to leave this class with is a highly trained sense of skepticism. If you'd like more on this, there's this wonderful book out there called Damned Lies and Statistics. If you don't know where your data comes from or you can't really analyze it and discover any truth of information from it, always look for context. Don't color your interpretation. I'm going to treat you like scientists even though you are business people. I want you to try to look at things from a perspective of, I don't know what this is telling me and I shouldn't make any assumptions until I can actually prove something or have something that supports it. Don't make wild claims. You should actually have data supporting your decisions. Like I said, data-driven decisions. Be aware that sometimes when you get questionnaires from respondents, they might not answer honestly, and or you might influence the responses if you're not careful. So what have we learned? Hey, we learned the W's and the H, and we want to use those to decide whether or not our data has good context and we should be using it. We learned about the 2 different major types of variables, quantitative and categorical, and additionally on top of that we learned about identifiers, which are another type of special categorical. So when you're looking at data from a different source, you should always ask yourself, what are the W's and the H so that I can nail down if the context of this data is useful for me.